Hello students. Next one is onto function or surjection. If the range of f is equal to the codomain of f. F maps A to B is a surjection if and only if the range of f equal to B, second set, or B equal to f of A where A belongs to A. You can also define it as range equal to codomain, or for every second set, take any element from the second set, for every B belongs to B, there exists at least one element A belongs to capital A, such that f of A equal to B. So these are the definitions for onto. So every element in B has a pre-image in A. Take an example. Take two sets A and B. In first set we are taking 4 elements 1, 2, 3, 4. In the second set we are taking only 3 elements A, B, C. So one is mapped to A, 2 to B, and 3 maps to C, and 4 is also to C. Okay, here F is onto, but F is not 1, 1. The reason is range equal to codomain. Every element in second set B has a pre-image. So each and every element is mapped with the first set. Range equal to codomain. So this is onto. F is onto. Okay, but what is about F is not 1, 1. So F is 1, 1 means for different elements in A have different images in B. But for 3 the image is C. For 4 also the element 4 has the same element C. So F is onto, but in case of 1, 1 it is not 1, 1 because f of 3 equal to f of 4 equal to C. For 3 and 4 the same answer, same image. So this is not 1, 1 since same image. Take another example. Take two sets A and B. Here take the same 1, 2, 3, 4 A, B, C. 1 to B and 2 is also mapped to B. 3 to C and 4 is also mapped to C. Here is it 1, 1 or onto? Okay, just check it. F is not onto because what is the reason? There is no pre-image for the element A. There is no, since the reason is there is no pre-image for the element A, and F is not 1, 1. Okay, the reason is for f of 1 and for f of 2 the image is same. For f of 3 and f of 4 has the same image as C. So it is not 1, 1. So this function is not 1, 1 and not onto. Okay, now bisection. So if the function f is both 1, 1 and onto. So then that is a bisection. That function is a bisection. Next one, equality of functions. Take any two functions f and g. If domain of f equal to domain of g, then those two functions are equal. Next one, constant function. The range of f contains one and only one element, that is f of x equal to c. For example, in the first set take 4 elements a, b, c, d. In the second set take only one element 2. If a is mapped to 2, b is also 2, c, d. So here f of a equal to f of b equal to f of c equal to f of d. All elements, the image is the same. So this type of function is called a constant function. Next one is identity function. Let A be a non-empty set. F maps A to A is called a identity function on A. It is denoted by IA. So take an example. If A equal to 2 elements in a set, A has 2 elements. Okay, the same sets we have to take here, A to A. So AB, here also AB. So this type of function is an identity function. Next one, composite function. If two functions f maps A to B and g maps B to C, then the relation A comma g of f of A, g of f of A, such that A belongs to A, is called a composite function of G. With the EF denoted by, it is denoted by G circle EF. Take three functions, three sets A, B, C. F maps A to B, G maps B to C, then G circle F. G circle F maps A to C. So G circle F maps A to C. This is a composite function. Real valued function. If X is any set, F maps X to R, then F is called a real valued function. For example, f of x by g of x, g of x not equal to 0, take log x, here x must be positive, greater than 0, and take a root of f of x, under root non-negative number, negative number is does not exist. So f of x must be a positive number, it may be 0 also, 1 by under root f of x. So here f of x must be just greater than 0. So these are the examples for real valued functions. Next one, even and odd function. If f of minus x equal to f of x for all x belongs to A, then here f maps A to R. F of minus x equal to f of x, then f is called an even function. Okay, if f of minus x equal to minus f of x, then it is an odd function. For example, take f of x equal to x square, f of x equal to cos x, f of x equal to mod x. So for all these are all the functions are even functions. So examples for even functions. Because if you take any negative number, it will be positive again. So you'll get again f of x. So that's why it is an even function. Next, for odd function, some examples are f of x equal to x. It is an odd function. Next example, f of x equal to x square plus x cube. Then this is neither even nor odd. Next one is polynomial function. The function f is defined on R by f of x equal to a0 plus a1x plus a2x square and so on an x power n for all x belongs to R, where n is a non-negative integer and a0, a1, a2 so on an are real numbers.